let's continue our chapter 3, quadratic function. Quadratic function normally from intermediate algebra you see is in the form f of x is equal to ax squared plus bx plus c. Now a cannot be 0. Everything else, if b is 0, then you're going to just have ax squared plus c. If b and c is 0, you're just going to have ax squared. So if a is positive, you're going to have a parabola open upward. Less than 0 is going to open downward. And then it's going to have a vertex. The formula for vertex is x equal to negative b over 2a. Once you get the x coordinate, you plug it in the equation, you will get the y coordinate. Now for this pre-cal, you also can have this formula for quadratic. F of x is equal to a times x minus h quantity square plus k. Again, a cannot be 0. If a is positive, it's open upward. If a is negative, it's open downward. And the vertex is hk. Let's look at our example. Find the quadratic function of the form y equal to ax squared that passed through point to negative 8. So I'm going to use this point. So I have y equal ax squared. Now when y is negative 8 and x is 2, I'm just substitute x and y in the equation. Then I'm going to have negative 8 is equal to 4a, which imply a is equal to negative 2. I have my a equal to negative 2. Now the equation will look like this. Y is equal negative 2x squared. Alright, so in this case my h is 0 and my k is 0. That's the vertex. So let's look at the next one. Find a quadratic function that giving vertex negative 3 and 4. So they give you the vertex and pass through the point negative 4 and 7. You have two formula, the first one or the second one. But I think since they give you the vertex, which means they give you h and k, because that's the vertex. So I'm going to use the second one. So I'm going to have f of x is equal to a x minus h quantity square plus k. Again, a cannot be 0. So my h is negative 3, my k is 4, alright? And I'm going to use this point, which means my y is 7 and my x is negative 4. So I'm going to substitute 7 for my y. We don't know what a is. My x is negative 4. Minus 3 will be plus 3 square. Plus k, my k is 4 because this is hk, the vertex is hk. So I would have 7 is equal to a negative 1 quantity square plus 4, or subtract 4 from both sides, I have 3 equal to a. So my a is equal to 3. You want the quadratic function, so I'm going to write this one. So f of x is equal to 3. X minus h, my h is 3. So x plus 3 quantity square, my k is 4. And that is the equation they're looking for. Now let's look at the next one. I just want to tell you that this form and this form are the same thing. So let's say if they give you f of x is equal to 2x squared plus 8x minus 10, and they want you to write in the form of f of x is equal to a times x minus h quantity square plus k. In order to write in this form, you need hk. H is vertex. Alright, so the vertex, I need to find the vertex. The vertex for the x coordinate is negative b over 2a. negative b over 2a. My b is 8, so I have negative 8 over 2. My a is 2, so that is negative 2. Alright, once I get my x, I can substitute it here to get my y. So I'm going to have f of negative 2 is equal to 2 times negative 2 quantity square plus 8 times negative 2 minus 10. Alright, so let's solve this. So I'm going to have 2 squared is 4, 4 times 2 is 8, minus 16, minus 10. So that is minus 18. So this is my vertex. My vertex is negative 2 minus 18, which implies that my edge is equal to negative 2 and my k is equal to negative 18 because hk is the vertex. So I can plug in the formula here. My a is the same a here. So the formula is f of x is equal to, my a here is 2, x plus 2 quantity square minus 18. That is the formula they are looking for. But if you want to check, alright, we can multiply it out. You can see that you're going to get this back. So let's check. I'm going to have 2. Expand this. It's going to be first term square plus 4x plus 4 minus 18. I'm just multiply this out, alright? So I'm going to have 2x squared plus 8x plus 8 minus 18. That is 2x squared plus 8x minus 10, which is the same thing. Alright, so let's look at more our next section. Let's look at our next section is polynomial function. Polynomial function is in the form of ax to the n plus a n minus 1, x to the n minus 1, and so on. So a here is your real number, x is your variable, and n is a positive integer. For example, I can have 5x to the 4th plus 4x to the cube plus 2x squared plus 9x plus 7. That is the polynomial. So we're going to look at the behavior of this polynomial. You can have a degree of even, which is 2, 4, 6, 8, or degree of odd, which is 1, 3, 5, and so on. The example I have here, the leading coefficient x, 5x to the 4, so degree here is 4, which is even. Alright, so let's look at even first, since we're familiar with this. So even, you're going to have f of x is equal to ax squared plus bx plus c, and if a is positive, you know that it's going to be a parabola open upward. So you're going to have parabola open upward, and the vertex is this point here. So it's going to have one turning point, so it's turning. It's going down and then going up. So it's going to have one turning point. As you can see, the vertex here is a turning point. And it's going to have a maximum of 2x intercept. It might not have 2, it might have 0 or 1, but maximum of 2x intercept. Alright, and then another, you can see the behavior of it is it's going up both sides, the left side and the right side. So it's rise both sides. Let me put it here. It's rise. I don't have room. Maybe I'll put it here. Rise both sides. Alright, so that's the behavior that we can see. it's rise both sides. So it's go up both direction. Now let's look at a less than 0. So you're gonna have a parabola open downward. Alright, so the vertex here is also one turning point. If you draw a horizontal line, it's gonna have maximum of 2x-intercept. It might not have 2 or may have none, but max is 2, alright? But then you can see the ending point is for both sides, right? So it's going down both sides. Now, when you have an even, it's going to behave this way for all the even. Let's look at the next even is degree 4. Degree 4, if A is positive, is going to be look like this, all right? But it's going to have 3 turning points. Instead of 1, it's going to have 3. 1 less than the degree, 1 less than the degree. So you're going to have something like this. As you can see, it's like this one, but it have 3 turning points. 1, 2, and 3. 3 turning points. It's gonna rise both sides, just like this one. And if you draw a horizontal line, 1, 2, 3, 4, it's gonna have maximum of 4 x-intercept. Degree 4, we have maximum of 4 x-intercept and 3 turning point. 3 is from 4 minus 1. Same idea, if it's less than 0, you can have something like this, but it's going down, like so. Same idea, it's gonna have 3 turning point, 1, 2, 3. Maximum of 4 x-intercept, but it's for both sides. So the next one will be degree 6, which I can draw it here, but it's gonna have 5 turning point because degree 6. If A is positive, it's gonna rise both sides. If A less than 0, it's gonna fall both sides, and maximum is gonna be 6 x-intercept. All right, same pattern. Now let's look at odd. Odd, again, is 1, 3, 5, and so on. So let's look at degree 1. Degree 1, if A is positive, it's gonna rise. So it's gonna look something like this. Okay, so no turning point. Right? It's gonna, on the left side, this is the left and this is the right. This is the left side, this is the right side. It's gonna fall to the left and rise to the right. As you can see, the left side is fall, the right side is rise. Alright, now if A is negative, it's going to be opposite. It's going to go this way. It's going to have no turning point, alright, but rise to the left and fall to the right. The next one will be degree 3 for the odd. It's going to behave the same if A is positive. but instead of no turning point, because it's degree 3, it's gonna have 2 turning point. All right, so it's gonna look like this. Oh, this one I forgot to tell you, it's gonna be 1 maximum of 1 x-intercept for both of them. All right, maximum of 1 x-intercept. As you can see, this is the x-intercept. All right, degree 3 is going to behave like degree 1. It's going to fall on the left, rise on the right, 2 turning point. All right, and maximum 3 x-intercept. Right, same idea. So 2 turning point. Same thing, fall on the left and rise on the right, and maximum 3 x-intercept. Same thing, if A is less than 0, it will behave like this one. It's gonna rise on the left, fall on the right. Okay. So it's gonna have something look like this. 2 turning point, same thing, maximum of 3 x-intercept, and rise on the left and fall on the right, to the right. So depend on it has degree odd and even, you can have an idea how the graph will behave. Let's look at the next section. Let's review our dividing polynomial. So I have this polynomial x to the 4th minus 13x squared plus x plus 35 divided by x squared minus x minus 6. So we're gonna do long division like we normally do. So I'm gonna write x to the 4th. Now I'm missing x to the 3rd, so I'm gonna put plus 0 x to the 3rd minus 13 x squared plus x plus 35. So make sure that you have everything complete, x to the 4th, x to the 3rd, x squared, x to the 1st, and constant. Now the divisor, I have x squared minus x minus 6. So it's in order, x squared, x to the 1st, x minus 6. So just like you do long division, you're gonna get rid of one term at a time. I have x squared here. I have to think, what should I multiply x squared to get x to the 4th? So I'm gonna multiply by x squared. However, I have to multiply to every term in here. So x squared times x squared is x to the 4th. X squared times x is minus x to the cube minus 6x squared. Next, I have to subtract this polynomial from the above. Because you subtract, you have to distribute the minus in everything. So I'm going to have minus here, I'm going to have plus here, I'm going to have plus here. So the first term is going to cancel out. The second term, I will have x to the cube. The third term, I have minus 13x squared plus 6x squared. Then I'm going to have minus 7x squared. Next, I'm going to bring down the x. Again, you want to get rid of this term. I have x squared here. How do I get x to the cube? I'm going to multiply by x. So I have to multiply x to everything in here. So x times x squared is x to the cube minus x squared minus 6x. All right. Now I'm going to subtract, distribute the minus in. The first term will cancel out because that's what we plan to do. The second term, I'm going to have minus 7 plus 1, so minus 6x squared plus 7x. Bring down the 35. Okay. Now I need to get negative 6x squared. So I have to multiply by negative 6. So negative 6 times this, I have negative 6x squared plus 6x plus 36. Subtract. Become plus, become minus, become minus. So the first term will cancel out. The second term, I end up with x minus 1. So the degree here is degree 1, degree here is degree 2. There is no way you can multiply something degree 2 and get degree 1. So this is the remainder. Alright, so this is how you would write it. You would write the quotient x squared plus x minus 6 plus, this is the remainder, x minus 1 divided by this divisor. So that's your answer. Let's see more example. Let's look at the syntactic division. Syntactic division is much easier than long division, but you only can do that when the divisor is in the form of x minus a. If the divisor is not x minus a, you cannot use syntactic. Alright, so let's look at this one. I have x to the cube minus x squared minus 7x plus 2 divided by x minus 1. So we can use syntactic, my x minus a. So my a is 1 here. So first thing you're going to do, you're going to write the coefficient of each term. I have degree 3, degree 2, degree 1, and constant. So everything is there. If something missing, you just put 0 times whatever the degree that's missing. For example, if I miss degree 2, I will put 0 times x to the second. So just write down the coefficient. So coefficient here is 1, negative 1, negative 7, 2. And then my a here, which is 1. If you have x plus 1, your a will be negative 1, right? You want to put in the form x minus a. So my a is 1. You put 1 here. You draw a line, right? So first thing you do, you just drop the first number here, which is 1. You just drop it. Then you multiply the a with this one. 1 times 1 is 1. So the 1 go here. Combine negative 1 and 1. Combine these two. You got 0. And then multiply 1 to 0. Put it here. 1 times 0 is 0. Combine these two terms, which is negative 7. You keep on going. Multiply 1 to negative 7. Is go here, which is negative 7. Combine these two terms, which is negative 5. The last one here is always going to be remainder. Last one here always going to be remainder. If you have 0 here, it means you don't have remainder and it's go in evenly. So this is your quotient. So this is start with degree 3. You're going to have 1 x squared, degree 1 less than the original one, plus 0x minus 7 plus remainder, which is negative 5 over divisor. So that is, or you can write this way, x squared minus 7 plus negative 5 over x minus 1. So this is syntactic division.